Deste lado aqui com o João já está. Esse lado já está. Já está, já. Sim, sim.
Good morning, everyone. Welcome to our second session. Welcome to our second session of our second BreathIN workshop. And we are going to start with the keynote speaker of today. And today, Edna will be our moderator for the morning. So please, Edna.
Então, bom dia para todo mundo, né? Good morning to everyone. It is my pleasure then to present to you Professor Gonçalves, Andrade de Santos, and he's going to be presenting his presentation is entitled Climate Change and Potential Impacts in Portugal. So Professor João Carlos is a full professor at the Physics Department, School of Sciences and Technology, the University of Thrace, Montes e Algodoro. Yes. He has a degree, his first degree was in physics and geophysics at the University of Lisbon, followed by a master's at the University of Thrace, Montes e Algodoro. Say a lot of this very long name. And a PhD in physics and meteorology at the University of Lisbon. And finally, a habilitation in physics at the, do you say UTAD?
Yes.
UTAD in 2012. Yeah. His area of expertise is in atmospheric sciences, climatology, climate change, and impact assessment, mostly in agroforestry systems and viticulture in particular. He's the director of the research and technology of agro-environmental and biological sciences. He is a very well-known researcher with more than 170 Scopus Index papers, handbooks, and more than 300 publications, including proceedings in scientific meetings. Yes, he has a long list of projects, European projects, including he was a coordinator of one Horizon 2020 on climate change and impact mitigation for European viticulture. I think he has a very, very long CV, and you could actually see some additional information if you guys go to his to the link in the website. But I don't want to make it a very, very long introduction. So Professor João Carlos, if you could actually start your presentation.
Thank you. Good morning. Good morning, everyone. And thank you for the invitation to participate in this workshop of the BreathIN project. My talk will be on climate change and potential impacts in Portugal, as already mentioned. And I will try to speed up a little bit to avoid a long delay. I would like to start by saying that climate emergency, it's what we are currently experiencing. It is a global threat, as we know, And this global threat can be illustrated by this picture, where we see the evolution of the global mean surface temperature that has undergone a sharp increase since the beginning of the I'm sorry, just to close here. Okay. Since the beginning of the 20th century, we have experiencing this upward trend in the global temperature, particularly in the last decades. And focusing also on the last year, we have, oops, sorry. Focusing on the last year, we have, it was particularly anomalously warm. We had 4 months with records in temperature worldwide. In fact, we have August and July being the warmest years on record, and June and September were also in the top 30 warmest months on record globally. So this kind of information illustrates the exceptionality of the 2023 year and the anomalously warm temperatures. We are getting used to this very warm weather, and maybe we don't even realize that temperatures today are 3, 4, 5 degrees above what should be expected in this time of the year. And in fact, 2023 was an exceptionally warm year, as we can see also in this diagram. And it was like an example of what we should expect in the future as a normal year. And we see that after June, in the second half of this year, all the months had anomalously warm temperatures well above the other years, the other previous years. This map is also very informative regarding this year, because we see that the orange or reddish areas are much wider than the bluish areas that cover just small, narrow regions, most of them over the oceans. And so the general idea was a planet much warmer than normal, than the average. But we are also witnessing more frequent and intense extreme events. This is the example of the heat wave that hit the Iberian Peninsula in July 2022, where we recorded extremely high temperatures, well above 40 degrees in many areas of the inner land. We have also severe droughts, extreme droughts in some cases, particularly in southern Portugal. The problem of drought is particularly noteworthy in Algarve, but also along the western southern coast of Portugal. And also floods. This is a picture taken close to Lisbon, but we unfortunately we also witnessed this large flood in Valencia, here in our neighbor Spain. Also, forest fires are a big issue, are becoming a big issue, like, for example, this picture that illustrates the severity of forest fires in Portugal in last September, with these plumes of smoke meandering towards the North Atlantic. The problem is that in many cases, these events occur as compound events and cascading risks emerge. and they are very difficult to manage by civil protection, by the authorities. When we look at past trends, and even in the last IPCC report, the fifth assessment report, already published in 2014, we see that in the last decades, there is a clear drying trend over the whole Mediterranean basin, and we are well aware of this. In fact, more recently in 2021, the IPCC in the next assessment report, the sixth already, identified major areas where agricultural and ecological droughts are becoming or have been undergoing a positive trend in their frequency of occurrence. The Mediterranean is by far one of the most exposed regions to droughts, both ecological and agricultural droughts. In a similar situation can be found here in Western North America, more or less in California and Oregon in the United States. So the Mediterranean, along with Western North America, are the two regions in the world where these kind of trends in droughts are more pronounced. The losses in agriculture are major. The estimates are very difficult, but according to FAO estimates for this period, droughts had losses of $37 billion, corresponding to 80% of all drought-related losses. So droughts are particularly damaging for agriculture. Floods, $21,000 million United States dollars. Now a contribution much lower of only 19% of all flood-related losses, because floods have huge impacts also on buildings, in cities, in other materials and human lives as well. Storms also very impacting, and wildfires, which are very significant for us, even though they are not comparable to the impacts of droughts, for example, in agriculture. And lastly, pests and diseases, that even the FAO recognizes that they are difficult to assess because we have too little information to make assumptions about this. Scientific evidence is provided in a large number of reports, such as these recent reports, including the synthesis report from 2023 on climate change. And the physical basis is already known for a while. Svante Arrhenius, a Nobel Prize in Chemistry, already talked about climate change, and he said that doubling carbon dioxide concentration will lead to global warming of approximately 5 to 6 Celsius degrees, which is not very far from our current projections. So climate change is old science. It's not a new issue. And even, just to highlight, Calendar, for example, published a paper in the Quarterly Journal of the Royal Meteorological Society, a journal that still exists, in 1938, already talking about climate change and the role of artificial or human-induced production of carbon dioxide on the planet temperature. So climate change, in fact, is here and is already understood by the scientific community for a long while, and it is related to the increase in carbon dioxide concentrations. For example, here we see the concentration in September last year and September this year, and we see the increase. Also, the long-term trend is exponential in the carbon dioxide concentration recorded at Mauna Loa Observatory from the NOAA in the Hawaii Islands, so in the middle of the North Pacific, far away from the main industrial areas. The carbon budget is unbalanced because we have more sources than sinks. Here are the most important contributors, the fossil fuels in general, coal, oil, and gas, also cement production, and land use. On the other hand, we have also land contributing to mitigate this contribution on the side of the sources, and the ocean that has been playing a major role as a carbon sink. Anyway, the sources are overcoming sinks and carbon dioxide continues increasing. The greenhouse gas effect was already well known in the 18th and 19th century, already explained by Joseph Fourier or John Tyndall, and we know that enhancing or strengthening the natural greenhouse gas effect, we will change our climate system, which is basically a system similar to a thermoelectric power plant, where the equator works as the heat source, while the poles act as cold reservoirs. So we have a heat reservoir close to the equator and two cool reservoirs at the poles. And then the role of the climate system is to transport energy from the equator to the poles and converting available potential energy into cinetic energy that is done by these conveyors that are usually called circulation cells, meridional circulation cells, such as these cells close to the equator, the Adley cells, the Ferro cells, the polar cells, and all of them play a role. In our case in Portugal, the Adley cell, this cell here, will extend, will strengthen, and move northwards. So this is why we are very worried in the Mediterranean basin about this, because the Sahara Desert is moving, is shifting to the north as the Adley cell is becoming stronger and moving to the north, pushing the Ferro cell to also poleward. In the case of Portugal, we have a weakening of the westerly winds represented by these blue areas, and the westerly winds are becoming stronger in the north. So as a result, we will have less precipitation in the Iberian Peninsula, as well as in the whole Mediterranean basin, and we will have more precipitation, for example, in Scandinavia. These two plots are very informative because they show that the current warming is unprecedented in more than 2,000 years. We cannot simulate this observed temperature increase without putting the human forcing on the climate system. If we consider only natural forcing, like solar and volcanic forcing, we are not able to reproduce, to replicate this observed trend. These are the contributors for this. I will jump a little bit. And regarding scenarios, we are working with different scenarios, with different emissions of carbon dioxide concentrations. Today, we are using the SESPs. And the SESPs are integrated in climate models that simulate the climate system. And we use also global, regional, and statistical downscaling approaches to get more detailed information at the local and regional scale. Anyway, the different SESPs, the different scenarios will have different implications in global temperature, and we see that global temperature in the worst case scenario can reach values up to 6 degrees of global warming. Global warming will not be equally distributed. Some areas will be much more exposed and vulnerable, like the Arctic and the Antarctic, and also some inner continental areas in terms of temperature. In terms of precipitation, we see that regardless of the scenario we will have in the future, a warmer 1.5 degrees world or 3 degrees world, and regardless of that, we will have a drying trend over the Mediterranean basin, and this is for sure. In the specific case of Portugal, we have already overcome significantly the Paris Agreement threshold of 1.5 degrees, because we have to take into account that we should start from here. And so we are already at 2.5 degrees of warming compared to the pre-industrial period. So we are well above the 1.5 or even the 2 Celsius degree warming. So Portugal is experiencing a very strong warming since the pre-industrial period. In a collaboration we have with the PIC, the Potsdam Institute for Climate Research, we are using a climate model ensemble that is innovative and based on the new SSPs. And we are producing maps for Portugal at a 1 kilometer grid resolution with bias correction, and we are having scenarios for temperature. Here, for example, we are using the SSP5 8.5 scenario for this medium range period, and we see that the average temperature, annual mean temperature, will increase significantly, particularly in all this area of inner Portugal compared to the historical period. So here we are having a warming of more than 2 Celsius degrees, but compared to this very recent period, if we compare with the pre-industrial period, this warming can be 4 or 5 degrees compared to that. In terms of precipitation, as expected, precipitation will decrease throughout Portugal, but particularly in the south. This area in the south, in Algarve and southern Alentejo, will be particularly exposed to this drying trend. Other metrics, such as the number of tropical nights, are interesting. We are calculating that. Here, the number of tropical nights will increase very significantly. And also the number of consecutive dry days, which are typically related to droughts, will also increase very significantly throughout the country, particularly in central Portugal in this case. The number of precipitation extremes will also increase throughout Portugal, but mostly in this area of inner south of Portugal, which will become more and more vulnerable to these precipitation extremes. And this is related, of course, to the Mediterranean, the southern Mediterranean conditions and instability that will result from that, for example, from much warmer sea surface temperatures in autumn or in spring. Dryness will increase, has been increasing in the Iberian Peninsula. Here we can see in these blue areas that we have been having a decrease in the Democritus index, which means an increase in drought frequency and intensity in all these areas. And another study we have developed shows here with Cristina, we have showed that this index, the Democritus index, will decrease in most of the Iberian Peninsula, being this area of southeastern Iberia particularly challenging for drought conditions in the future. Another study we have developed show that aridity, this is the aridity index for the major river basins in the Iberian Peninsula, and the shading areas in color are the regions with agriculture, used for agriculture. And we see that we will have an increase in aridity in all the hydrological basins in the Iberian Peninsula. And also the volumetric soil water will decrease in this area. So we will have less precipitation and less water in the soils. On the other hand, we have conflicting of interests because we have the irrigated area. For example, in the Tagus Basin in 2000, the irrigated area was very small, and in 2019, the area was already around 1/4 of the whole agricultural area with irrigation. So irrigation is becoming a big issue in agriculture because the farmers tend to respond to climate change, watering their crops, irrigating more. And this is unsustainable in the future because, as you saw, all these water basins will have less water available, and we are at the same time increasing the areas with irrigation. So there is clearly a conflict here that will, I would say, explode in the next decades. In terms of local and sectorial responses, we have been working a lot in viticulture, for example, determining regions for the different denominations of origin of wine production in Portugal. We have computed different classes of agroclimates, different agroclimates based on different agroclimatic indices. This kind of information is useful for winemakers because they can understand the strength of climate change in their own region and support their decision based on all the information that is available, namely from other regions' information. So the farmers, the winemakers in the northwest of Portugal, which is a cooler and moister region, can learn from farmers, viticulturists from southern Portugal, because within a few decades they will have a similar climate as we can find today in Alentejo and in Algarve. We also produce very detailed information. Here, for example, is for Symington, for a parcel in Symington under the PRR project, Fine and Wine. And we are producing data at a 10-meter spatial resolution, also with climate change scenarios. We also simulate climate change by using crop models. And in this study, for example, we identified that watering crops is not enough. It's not by itself an adaptation measure that can be used to solve all the problems. We found that even providing enough water to grapevines, they will have a reduction in yields. And this is because of heat stress. So even if we overcome water stress, we will have the problem of heat stress that will persist and will strengthen in the future, because the plants will suffer a lot from the very warm temperatures, even if they have enough water in their roots. In terms of human health, just very briefly, we follow usually this One Health approach, and according to the World Health Organization, it's estimated that 250,000 additional deaths per year should occur owing to heat waves, malaria, diarrheal diseases, and child malnutrition. Diseases related to heat stress are particularly important, as more frequent and intense heat waves lead to heat strokes, for example, dehydration and other problems. Vector-borne diseases, aggravation of respiratory diseases, it's also a big deal nowadays, and it will increase in the future. But also the problems of food and nutrition insecurity will become also a very important issue in the future, as many crops will die or will suffer a lot, as we see in viticulture, but also cereals and other major crops and basic crops for human consumption. And also the problems of scarcity of drinking water leading to triggering problems of diarrhea, cholera, hepatitis, and other problems related to the lack of access to water and hygiene and public health conditions. Diseases associated with climate disasters, as we already saw in Valencia, for example, and also, very importantly, impacts on mental health, because all these changes and extreme events will lead to problems of such as anxiety, depression, post-traumatic stress disorders, and other problems of mental health. Inequalities and vulnerable population will also be more exposed to these problems. Thank you. I cannot hear. I don't know.
Muito obrigada pela sua apresentação. Yeah, so I think we actually, your presentation was not only important for Portugal, but actually for the whole world in general. So we can worry about what we are doing now, how much we are actually contributing to this climate change. Cristina told me that we will have questions at the end of the session. So if you would be kind enough to stay with us, it would be really appreciated.
Before coffee break.
Before coffee break.
Yeah.
Yeah? Okay.
Thank you.
Thank you. Yeah. So our next presenter then, our next presentation is Professor Francisco Carvalho. So he's going to present a measuring perception of air quality environment in a classroom. And the work then is done by Francisco, Cristina, and Rui as well. And allow me to say a few words about Francisco. So he has a PhD in mathematics, yes, and his research is mostly related to statistics. He started teaching in 1995 as an invited assistant. And since 2000, he's an adjunct professor at the business school here at IPT. Yeah. He has taught many disciplines. He's an author of several research papers and book chapters. And he's also chaired several organizing committees for international conferences. Yeah. So he is a member of the NOVA Math Research Center. And for the last 8 years, he's the director of the management school here at IPT. And so he, among other administrative positions that is related to his position. Yeah. So Francisco, if the floor is yours.
Thank you so much. I apologize, but I will not talk about lights. I will not talk about fires. I will not talk about heat waves and all that stuff. It's not my métier, so I apologize. I will not talk about it. But I try to engage you in a few things that we are doing in these projects, namely to measure the perception of the students they have on their indoor air quality. Of course, air quality, we can measure it. There is some stepping, I'm sorry. Air quality, you can measure several indexes. CO2 levels, temperature, humidity, all those indicators that you know so well, you can measure it efficiently, and you can compare it to standards that are available everywhere. So this is not my concern. That I can measure with precision. What I intend to do is try to figure out how the students feel they feel inside their classroom, how they feel that the weather, the air quality impacts on their living inside the classroom. That's we are doing on this part of the project. Data is just coming in. For some places, we already have some raw data. The database needs to be cleaned and so on to be sorted out. So I choose the location Tomar because we had that information available and more data to collect. So that's why. We will not talk about Leiria at this point. It's just a previous study. I will not talk about Leiria, nor branch, nor Thrace. They will come up later on. But this is the beginning of the study, trying to figure out what can be done, what can we do with this data. That's the big issue around here. So we pick up the data that we had from ship. I believe the data will come shortly. Down and okay, just to see who are we talking about. So mainly young students, so first years, undergraduate students, less than 21 years, and their gender related information. That's not a big issue, but we tend to know who is addressing to. Okay, that's the basic idea. Now, when we're talking about overall health feeling, we ask the students, how do you feel? What do you think is your overall measure of health? How do you feel? That's the basic idea. All of them, most of them got to a good feeling. Between good and excellent, we get most of them. The median is, I'm sorry, the software is in Portuguese, so the output is in Portuguese, but I'll figure out to translate this information. The median is 4, basically, it says everyone of the students are good or excellent on their feelings towards their overall feeling. Okay? Basically, okay, we are good. Now, then we ask a few things other than how you feel. And then how do you rate the air quality? A scale 1 to 5. How do you rate the air quality in your classroom? How do you rate it? Okay. If we get to dryness, humidity, dryness, static air, we can see, looking at the median, that everything is even, fair. That's the answer most people would. It's fair. Okay? That's how I feel. But if we go to dusty, to odors and smells, that's a different story. They all have the feeling it's smelly. They all feel, most of them feel that something is strange. There is dust in the air or something like this. Okay? That's the median is 2. It means 50% of them is 1 or 2. So the lower ends of the scale, it means more dusty air quality is poor. So that's the basic idea. Okay. So not with dryness, not with humidity, not with darkness or some air, but to those questions, okay, they feel something. We have to address this. Okay. Just to explain why the median, why that values and so on. So all of them, basically 50%. Can be up and down these central points. This is fair. Okay. So 50% of the students go, the air is not so fair, and 50% the air is fair enough. Okay. That's the basic idea. So 50%. But if we go to the other end, that's a different story. The symmetry is completely different, and the data is pulled from this left side. Okay. So they feel that unpleasant smells, odor, and dusty air is poor. Okay? So it's very good. Okay? This is interesting. This is becoming something different from the fair or from whatever. It's the normal. Okay? So that's why this median is 2. And if you go to a symmetry, all of them is negative, dryness more or less, but here it's positive. Okay, means on the left-hand side, the low part, it's heavy tails, more tails. Okay, more data. So lower. Bump on the left side. When you go to respiratory symptoms in the classroom, how do you feel in the classroom? The question was, how do you evaluate your respiratory symptoms in the classroom? Okay, again, scale 1 to 5 plus not applicable point. Not applicable, it's this 6 that happens here. This point 6 is not out of the scale. I put a 6 to be different, of course. It's out of the scale. So 1 to 5 is low to high, again, but not applicable. It's out of the scale here. And strange enough, since they all feel okay, so it's not applicable. Not for sore throats, not right cough, and so on. All this gets to the median gets to 6. So most of them, hardly most of them, do not feel anything about this. Just starting to feel something about here, the stuffy nose. 4. It's okay. It's not so well, but run. Okay. And again, the symmetry goes all the way negative, so local tells. Not so many people answer this question, that's why. Look, the 6, not applicable, not applicable. Just here on the stuffy nose, you can see there's a point that is higher than all the other, meaning no one answered, in fact, the question. Not applicable, not applicable, not applicable. And again, all of them not applicable. Okay. In fact, if it's not applicable, or if they do not understand the question by itself. That's a point. And I was getting this data, cleaning the database, because we need to clean the database. And I was wondering, are you sure this is all not applicable? It means, or do they understood the extent of the question? I have some other doubts here in, again, somewhere in the presentation, but we'll talk about it later. Okay. How do you evaluate your respiratory symptoms in the classroom? Yeah. So all of those questions are in the same. I separated in 2 groups that question, because the question is still the same. How do we evaluate it? I put these items in one data set and another data set here. Because they are a bit different, you know. Just because look, the first ones we're talking about stuffy nose, dry cough, hoarseness, shortness of breath, cough, eye irritation. But here we're talking about tiredness, difficulties in concentration, headaches, eating issues. Okay. So it's a bit concept, different concepts. So I separated them to understand, are they at the same level? Okay, so the median, again, skin issues, 6, not applicable. Okay, skin issues is not so common issue. Okay, I might understand. It can be 6. No one understood that. Okay, but headaches, concentration difficulties, and tiredness, high ends. High ends. It's good. Something is going on. They are picking these subjects as we have problems. Although I feel good in my classroom, everything is okay, but here they're showing in some items something is different. And here is the skin issue, okay, and then something happens in here. If they diminish, they have, or they have worsened. That's the median we had here before. When the median is 4 and 5, it means worsened a bit or even worsened. Okay, so something happens inside the room, basically related to tiredness, headache, and concentration difficulties. Okay? That they can point it out. It happens. Okay. Now, do they improve? These symptoms improve when we go outside? Yes. Okay, there's no doubt about it. It is a straightforward yes. So 64.5% of them, yes, we get better when we get outside. It was an expected conclusion, but okay, it's there. It's there. Basically, yes. A few, I don't know, but in fact, yes, it's a point that should be pointed out here. Now, I'm here and I'm having here I put it here to understand what we are doing next. These are the expressions that the students came in. They were engaged in answering these questions, these sentences, and they would say, I strongly disagree to I strongly agree. Okay? Do you agree or not with this expression? So I'm putting here just to a reminder of what we are dealing with next, because the other question was easy. Good, bad, and so on. Now, strongly agree or not agree with a sentence. And we're talking about I'm satisfied with the classroom, is large enough, the seats in this classroom are comfortable, the arrangement of seats in this classroom is appropriated, and is fitted with the appropriate level of classroom technology. Again, I separated it into data sets because I found that it's interesting to separate in these two data sets. So just keep in mind, these are the questions. The variables will be shortened, but these are the questions that we have to address, and we go dealing with the data. So what we came up with, satisfied with classroom and so on, are shortening of the sentences. So we can keep in mind. Okay, so basically, the median let us tell us that 3, 3, 3, 3, 4, 4. It's neutral. I don't agree too much. I don't disagree too much. Okay, so I'm satisfied in classroom. Basically, I don't have anything to say good or bad about being in the classroom. It's large enough. It's on the, let's say, agreement size of the scale, and the seats are comfortable. Doesn't mean anything. Seat arrangement appropriated doesn't mean anything. And again, level of appropriate technology is getting agreements and of the data set. This was one of the things that I found this is a bit strange to me, because I know for a fact that some classrooms do not have comfortable seats. I know for a fact that some classes, students complain about the sittings. So, but there's smells fishy around here. I don't think so, but let me check it later. In fact, there is a classroom here. The seats are not like this one. They are harder seats. They're not so comfy to be at the class. So this is strange. We'll check it later. Okay. So those are the medians. I don't know if everyone understands why I'm talking about median. I'm not talking about average or mean, because this is not a continuous variable, so you cannot talk about mean. Okay, but for those who might not understand, just I believe everyone understands what I'm saying, but just a reminder. Okay, so even symmetry or negatives. If it's negative, it means it's on the upper part of the observation. It means something like a bump on the right side. Okay. Now, here. Okay, let's go. This is the second part of this data set. Sorry, it's a bit. I'll try to. The lighting the classroom is appropriated. I have difficulties in seeing the instructional materials displayed by the professor in this classroom. I'm often distracted by other visual items in this classroom. So all the three first question sentences are related to lighting. Okay, lighting is okay. I can see everything for the things that are being projected. Okay, next. I'm often noise coming from outside. It's a problem. But it's easy to hear a professor in the classroom. Computer is, these two questions are about sound. Okay. Next, computer access during class would enhance my learning in this course. The temperature in the classroom is comfortable. Okay. These are two other, but I included it here just to not over to issues. Now. Here. It's this one. It's the symmetry and this difference. Difficulty in seeing displayed materials, distracted by other visual items, and noise from outside is a problem. I believe I have the graphics here. not what over and over graphics. I don't want to bother you with so many graphics, but here we have a problem. As the lightning is 4. 4 it means upper end. So on the agreement side, let's say everything seems to be okay. Most of the people think that the lighting is good enough to be at the classroom, to see the materials, and so on. So for this end, more or less everything is okay. Now, as to difficulty seeing display materials and distracted by other visual items and noise, that's a different story. Okay. Now here they pointed out that they don't agree so much with this point. So there is some difficulties here in these conditions in the classroom. It's easy to hear the professor, not a problem, and the computer and the temperature, not a problem also in this data. Now, I said something earlier about the sittings. Yeah, okay, let me check. I made just a crossing of some data just to check. The one that is probably most uncomfortable is this room. Unfortunately, we had just two of them, so it doesn't have any weight on the data. But the big number is room 268. It's in fact an auditorium. The room is fine. It's just like the other ones. It is fine. I believe the question here is probably too many students on this classroom makes it a bit uncomfortable. Because if I compare with 254 and most of the other rooms, the room is it's one of the biggest rooms. It's 90 seats. It's quite good. The seats are okay, but I believe it's due to the occupancy of this class. Too many students, so it's an auditorium. People next to each other may be the point. The students pointed out as being uncomfortable, not by the seat itself, but by the condition they are sitting on to understand this. Okay, so I didn't understand why. That's it. Process with the two last questions. I am satisfied with the condition and I enjoy coming to the classroom. Although should be expected to have some correlation, the independence cannot be ruled out. The data, more or less, we know we have some issues about having chi-square tests, but I perform some non-parametric tests and still goes like this. So the independence cannot be ruled out. Okay, it should be some correlation, but not enough. If evidences are not enough to rule out independence. So they are basically, I'm saying that they are independent. So the conditions do not have anything to say with I enjoy or not coming into this classroom, basically. Now, let's start to have some fun, because this is just checking the information without adding too much knowledge into this one. This is just a prior study, of course. Data is just getting out to us, and some data needs to be cleaned out. But here I'm trying to have some factor analysis to understand if there are other underlying factors that could explain some of the results that the students pointed out. The first thing to do is to get a correlation matrix and try to figure out where the variables are statistically significant. Not too much. I just have one spot here or two that make some sense in this relationship. 0.507 and some forced something, 459, 478. So not so strong of evidence of correlation between these variables. So let's see what expects us from this effector analysis. Well, the statistics are okay. Either the Casimir Olkin or the Bartlett tests gives you permission to go on with this effector analysis. So not a problem with that. But let's see what happens when we try to figure out which components or what components or many components are underlying these results. Okay. So we figure out three components, and the three components explain mostly 52% of the variance. Variance is what we need. We need something to jiggle about. Otherwise, everything is equal. We don't have anything else to add. So if anything moves, that's what we want. So three components will give us 52% explaining the results, the data that was answered by the students. Interesting. 52%. Not too much, but not too low also. And three components are good enough to make some projections with in 3D. So even for some drawings, for some nice reports, we can have some 3D results, images that would be working fine. So what are those components? They are expressed here. So the first component is this one. It gets you from the lighting issues, lighting appropriate for lectures, appropriate technology, satisfied with the classroom. The second one, the second component is physical conditions, let's say. Large enough, seats here to the professor, temperature is comfortable. And then the third component, it's other things. Noise, difficulty in seeing display materials, distracted by other visual items. Okay? This is the main core that we are going to deal with. These are the three components that we must dig in to understand. And to compare, that's the second stage of this study, to compare it with not only other classrooms, but again, between institutions that we are aiming for. As soon as we have some more data, we can get this one and start to make some comparison. And as long as the time goes by, to compare it with in time, what is going on, what's going to happen, if the feeling of the students are in fact going to change or not, and if the conditions, physical conditions can be measured, are in fact moving on or not, and if they are correlated or not. That's the big issue. For now, that I would like to present. There are a lot more things that can be done, but at this stage, the data is not big enough for us to start doing some comparisons. Otherwise, we lost significance. Otherwise, we lost many things. But for now, it's interesting to find out about these things and to try to explain these various components that are the factors that are underlying the students' answer for the items that we addressed on these questionnaires. Okay, so more questions, more questionnaires will give you more data, more support, and then more things to show you. So thank you so much for your attention. Questions later on, perhaps? Yeah, okay. So let's explain.
So thank you, Francisco, for the interesting analysis of our results. Yes. And let's hope that we are going to be able to get not only the Leiria and the Greek one, but also from Cyprus. So I think we are a bit delayed on that. So the next talk before, and the last talk before our coffee break then is raising awareness among high school students about indoor air quality and well-being issues. And it's going to be presented, I think, together by both Anabela Veiga and João Souza. And just allow me to give a brief introduction for both Anabela and João. So Anabela is a professor at the Department of Civil Engineering at the Polytechnic Institute of Leiria, where she teaches various subjects in the fields of engineering, geology, and soil mechanics. She got a degree from the University of Coimbra in geology followed by a master's in geosciences and land management, also from the University of Coimbra. And she continued to a PhD in geological engineering at the same university. So besides then being a professor at Leiria, she is also a researcher at the Geosciences Center of the University of Coimbra in the cluster of geotechnology. Yeah, and research interests are focused on solving problems related to geological environment, geotechnics, and the availability of resources for sustainable development. Yeah, so she has published many papers and conferences and peer-reviewed journals. So João then holds a PhD in electrical engineering from the University of Coimbra, and he is a professor at the Department of Electrical Engineering at the Polytechnic of Leiria. You are also a researcher at, I would probably say wrong, INESC.
Yes.
Yeah,
Perfect.
Coimbra, in the field of rational use of energy and power systems planning. And his main interest is in the use of artificial intelligence in energy systems planning, being involved in research projects and supervision of work related to load forecasting, load profiling, machine learning, energy efficiency in buildings, and smart meter data technology analysis. Yeah. So please, Annabella and João, and I have Sandra there as well. So the floor is yours.
Good morning. Thank you, Edna. This present, last Edna, where will be shared between João and me. Sandra is also part of the team. This is the core of the team because we have more people in this team. At the moment, we have 7 teachers from high school. In this moment, we will present a project idea that we are implementing in high school education schools, and these schools are not part of the breathing project. The project idea is to raise awareness among high school about indoor quality and well-being issues. In this presentation, we will talk about the motivation to carry out this work. What main proposal, the characterization of our first target high school, present the work plan, and in conclusion, give you the status of the implementation of this project idea. Our motivation goes through involve other levels of education, collect more information of the same environment parameters, and get more. Increase younger students awareness these issues, encourage critical analysis and result, and promote the identification of good practice. And we believe this project increase our health, our think about our health, and we hope increase our successful. Okay. The main proposal involves replicate measurements of the same environmental microbiology and light parameters in high school, involve more students, characterizing more school spaces, and also for sustainability issues, monitorize the equipment pushes for the breeding project. Now, João will explain how we are going to do this.
Thank you very much. Good morning, everybody. And thank you very much for the invitation to participate. It's a great pleasure. So keep on going, as Annabella said, and keep the pace of Annabella. Well, I would like to say that this main proposal is to get closer to high schools, to involve younger students, younger than our students in Polytechnic, to be involved in these thematics, probably to increase their awareness and to get some of their contributions, because young students often have good ideas. So I would say that we want to involve students in the science and technology fields of study, and our main concern is to try to match the breathing activities that we want to propose them with something that they are really studying in these fields of study. So we are thinking about taking the advantage of having students working on methods, and we are gathering lots and lots of data. As Francisco said in the last presentation, we want them to dig into this data, to make some data analysis, to have some statistical analysis. So it's a good way to involve them in this kind of fields. Then we are talking about sensors that are measuring different physical quantities, and we are talking about physics principles, as the one that Tomar team yesterday told about lighting, and it was quite interesting. And we know that it depends on lots of physics and even some chemistry, because we have some chemical reactions. So we want to, while the teachers in the high schools are exploring these contents, probably they could be involved in these thematics that we have in this breathing project. We also want to collect air samples, as we are doing in our institution, in our Polytechnic, to make some microbiological analysis. So we want to include this in the domain of biology. And sometimes the high schools propose to the students something that is more transversal. So to combine these different areas, and probably we can propose something different to the students, because we can help them in development of their transversal skills. We want students to work in groups. We want students to research a little bit. We want students to organize data. We want students to produce reports or help us to produce reports. And even, for example, to prepare an oral presentation in Portuguese or in English, and it could be quite useful for their education. Well, to make you know about the schools that we want to explore, we want, our main aim is to study 4 different high schools. In the present school here, we want to, and we have already managed to get closer to 2 different schools, and our plan is to extend to 2 more schools until the end of the project. Well, looking in more detail, thinking about people coming from abroad, we are in the central area of Portugal. We are now here in Tomar, this corner. Leiria is something like 46 kilometers from Tomar. That's where we have the largest high school that we want to explore and to work in cooperation. The other school is located in Marinha Grande, a small town quite near Leiria, something like 30 kilometers. So we have these 2 different schools in Leiria and Marinha Grande to cooperate with us during the present school year. Just to give you a perspective of these two schools, talking about their dimensions, you can get information about their dimensions here in this second column. We want, as I have said to you before, we want to work with people, with students from sciences and technology. From the largest school, we have two classes or two groups of students belonging to the last secondary school. So we are talking about students in a range between 17, 18 years old. And with the School of Maria Grande, we will work with the first secondary school here, something like in between 15, 16 years old. And for this, well, this kick-off preparation, kick-off school year to cooperate with these schools, we have at about 72 students working, cooperating with us in the scope of this breathing project. And well, we have already designed a work plan to do that, and we have already discussed it with the different high school boards and also high school teachers. And our plan, well, we would like to divide it into these three columns just to check the involvement of the different partners. It starts from us, BreathIN team in Polytechnic of Leiria. First of all, we want to prepare. We have already prepared like a characterization sheet for each specific room being characterized, being analyzed, with information about the area of each classroom, the occupancy profile, if it has the windows areas, or many windows the classroom have. But also, for instance, we have been thinking about the cleaning timetables because it could have some relationship with the different air quality measurements that we will analyze. So after that, we put on the hands of the teachers the choice of the classrooms according to some specific criteria. It could be the area of the classroom, it could be the occupancy profile, it could be something they can imagine that probably is not so good, like the luminance or the air quality. So they are free to decide which classroom to be analyzed. And then, as the first joint task, we will involve the students to have the first meeting with them, describing the main aim of the project, the parameters that we want to analyze with them, but also to show them the pertinence of this analysis, but also including here the reference levels. We want to show them the reference levels that we must attend according to the legislation, to give them that perspective. After that, we want to install the same instruments that we have here. Yesterday we had in this table, and we are using in our project. So collecting information about the air quality, the luminance, to allow here the luminance measurements, and also to collect examples to subject to microbiological analysis. After that, that's the moment where, as the Polytechnic of Leiria team wants to go to the school to remove all the equipment, to download this measured data. Probably spend a little time pre-processing this data, looking to the data before passing this to our partners. It would be good to be sure to have some trust in these measurements. And after that, and during the classes, the idea is to put the data available for the teachers to explore directly with the students during the classes, to allow data analysis, and probably they could find some non-conforming patterns. And the idea is to allow them to have some room to suggest some corrective measures to propose in their spaces. And at the end, what we want, it could be interesting to have some publications, some results, and also to disseminate these results by preparing a joint workshop, probably combining the different high schools. We have to think a little bit about this to disseminate the main project outcomes. Well, to conclude, I must say that the meetings with our partners, at least for these two schools, that we want to analyze during this school year, the meetings were already done, these first meetings, and they have already accepted and they have proposed the work plan that we have. The kickoff meetings with the students are already organized for next month, in a few weeks, and the measurement equipment will be installed in a few days. Just to confirm, 1 week. Next Friday, we will go to the first school to install the first equipment in one of these schools. And I must, of course, recognize, well, the acceptance and the involvement of the high schools teachers. It's quite important for us to have their cooperation. I'd say that we can have young students involved and engaged with this project if we have enthusiastic high school teachers and lecturers working with us in cooperation, but involving and motivating the students along the class to get the better results for us. Okay, that's it. Thank you for your attention.
Thank you.
Well, thank you very much for your very interesting presentation. And I think that's part of the project, yes, to be engaging not only our young people at the universities, but actually getting further than that and pushing the topic of air quality and how our students learn how can we improve their environment where they're studying. Yeah? So I actually got some very good ideas. So maybe when we go back to Cyprus, we will start implementing it as well. So thank you very much for that. So we are open for questions then for the three presenters that we had previously. So Professor João Santos. Yes. And then
Francisco.
And then Francisco, and then Annabella and João. So would you like, is there anyone from the audience that, or from the online audience that would like to ask any questions? Yeah, so we have two questions then from the audience here. Maybe you can speak louder or
Louder.
So thank you all three. Presentations were really nice. I have a question from Francisco. I may have missed it at the very beginning, but the responses, was it before you put the plans or was it after the distribution of the questionnaires?
Before, much before. The plans are just arriving now, so it's a precondition that we are trying to assess a baseline in order against to compare the information.
And then compare again the same after the plans.
Yeah, that's the idea. It's along the way trying to measure differences. The interesting part of it is how effects does in fact the plans or the other elements that are being made on this living lab. What effect on the students? That's the basic idea of the project. How can we change the idea that the students have for their indoor air quality conditions?
Yeah. So Stavros?
Yeah, I have a question for Professor Santos. I would like to ask about if there is any projection about the quantity of the water vapor in the atmosphere and how this will, if there is an effect of, what's the effect of water vapor in climate change as a greenhouse contributor? Is there such a projection?
Hello. I think I'm not sure if I understood the question, but I can say that green water vapor is very effective as a greenhouse gas. So greenhouse gas effect can significantly, the contribution of carbon dioxide, of water vapor isolated can play an important role in greenhouse gas effect. However, because we have already the atmosphere in terms of radiation saturated of water vapor, the real potential for more warming from water vapor is a little bit limited when compared to carbon dioxide, for example. Carbon dioxide, methane, nitrous oxide, HC, fluorocarbons, and other greenhouse gases still have a large way to improve, to increase in the atmosphere. So overall, I can say that water vapor is very important as a greenhouse gas, but the current content of water vapor is already close to saturation in terms of potential for global warming.
Yeah. I have a question then for Anabela and João. So how difficult was it to approach the schools, the high schools, and actually get them involved?
It was easy.
Very easy.
Yes, because they are friendly. We work a long time together in other projects.
Okay.
In this case, it was easy.
Okay, thank you. Yes. Any other questions? No? So thank you very much to all of you for your presentation. I think we are going to go for a brief coffee break.
Yes.
And then we are going to come back for the second part of the workshop. Yeah, thank you.
Thank you. Just a quick break, and we will be back soon. Okay. Where's my cable?
All right. So our next speaker is Cristina Andrade. I'm sure you all know her. She's the very heart of this project. A few words about her. She holds a degree in geographical engineering, a master of science in geophysics, and the second one in mathematics. Her PhD focuses on environmental sciences. She teaches a series of classes in the university here. Most importantly, she's the founder and has been the director of the Natural Hazards Research Center since 2014. Is that right?
Yes.
Okay. Her research areas are natural hazards, extreme events, geostatistical approaches in meteorology and climatology, and climate change impacts, among others. She has published several research papers in peer-reviewed journals. She's the editor of 4 books and the guest editor of 4 special issues. And she has been the principal investigator in some very important projects. And currently she is the PR of this project, the BreathIN project. Cristina, the floor is yours.
Thank you. Thank you. So once again, thank you for participating in this our workshop. And we had an adjustment to our schedule to the presence, which I appreciate, because our main goal is also not to reach our other higher education institutions, also academic engagement, but also decision makers like the vice president of a municipality of Mação, a municipality nearby Tomar, and in the Mid-Lagos region, which is for us an honor for you to be present here and to listen to our communications and our project. So, if you will, I do not see my presentation. So, my apologies. Okay, thank you. So I'm going to start to overview some aspects of the equipment of monitoring equipment that we already have. So I'm going to assess. This is a preliminary assessment still, okay, of the impact of the 2024, a few months ago, in September, of the wildfires that occur in central Portugal, and the impacts that we are acknowledging to have here in outdoor air quality in Tomar. So, of course, a first overview. Forest fires, I'm speaking to a broader audience, not all researchers and the audience is aware that forest fires can be either natural or human induced. And of course, here in Portugal, we have a problem, like in the majority of the countries that are suffering with this crisis of forest fires. The majority of them are human induced indeed. And of course, this has impacts in air pollution. And those impacts are either by the smoke plumes that you can see a satellite image of forest fires, not here in Portugal, but you can clearly see the huge plume that arise from the forest fires. And of course, this will impact and worsen air quality in cities, and of course, public health risks occur and also increase. And the technology
Okay.
is not.
Okay, try again.
Okay, so of course we can divide these impacts either in environmental impacts such as carbon emissions, air quality, and one of the parameters that we are monitoring now are the PM, the particulate matter, PM 2.5, PM 10, and even PM 1. It is very important for us to for you to be aware of this, because I'm going to show you results from our monitoring equipment regarding the air quality precisely on those produced fire particulate matters, okay? So we also have detrimental impacts due to the deforestation and habitat destruction. We also have soil degradation. This is very serious here in Portugal because in some terrains the slope is so steep. When the first rain occurs, it washes the fertile soil. So the process of soil degradation is highly increased upon a forest fire. This year we have already had a huge event in Madeira Island. The slopes are very steep, and there the problem is going to be very bad during this winter. So human health also is going to be impacted, respiratory and cardiovascular issues, chronic conditions also, and of course, stress. Vulnerable groups are the most affected, and mental health, post-traumatic stress disorder. The 2017 forest fires that occurred here in Portugal, more than 100 people killed. The majority of the people, around 60, died in one day, in one road, and the families are still suffering from post-traumatic stress. So this is very serious indeed. About environmental and health impacts on a global and regional effects. Of course, we cannot contain the plume of a forest fire in a limited region. And I'm going to prove to you that we kept some of the particulate matter, some of this pollution here in Portugal, though those forest fires, those that you are seeing here, yes, they are from Portugal. And you can even see the flames. So they are indeed a big problem for us during the season fire, but our season fire is increasing. The length of the season fire is increasing indeed in some years. So this poses a very serious problem. So what was the status until August? You see how this can change dramatically in a few days. So this is a report that I retrieved from the European Forest Fire Information System, and we were indeed below the average for the reference period between 2006 and 2023. Of course, the worst season Europe-wide was in 2017. And indeed, everything changed during August, and then in September, the crisis was so huge that our Prime Minister declared the state of emergency in the affected areas. So for you to see the statistics, you can see that you have the average in blue, and then you have the year in our year 2024 in hectares here, and suddenly you see a slope. So the mean value is this blue color, and suddenly, whoops, a huge slope from beginning of September of 2024. And this is very concerning. I'm going to show you the region, for those who are not familiar, of course, with Portugal. So the majority of the areas that were affected were nearby Aveiro city, here in this region of Portugal. Here are the regions that were both affected, and including this region here, Severo do Voga, that has the size of 11 times the size of the Lisbon. And it was marked as one of the worst forest fires in Portugal history now. And I'm going to show you the region. The region of Severo do Voga is this region here, but I want to state that all of this area here near Aveiro was affected during a long period, too long periods during September. Okay, so here you have the status between the day 17 and 18 of September 2024. Okay, the areas are orange are burnt areas on the 17th. On the 18th, the fire spreads, and you see the areas in the red color. Okay, Albergaria da Velha here is here in the map, and Severo do Voga is here. You can see the extension of the region that was affected within 2 days. Within 2 days. That's why it was very, very severe. And may I say this? This is a highly populated area. So, and from the industrial viewpoint, many industries are also centered here. So this was very serious problem. Here you can see another outlook of the problem, and you can see that it spreads. You have 4 regions delimited here, the region of Severo do Voga, the region here in bluish, with this bluish color here. So the orange are burnt areas, okay? So they separated the regions in 4 regions, and between the periods of 23rd until the 13th, this area burnt in all of this region here, all of this northern region in Portugal. So we are a small country. You can see that almost half of the country, a little bit burnt, not a little bit, but in scarce areas, but it burned. Okay, so Tomar outdoor parameters. Of course, we have already one instrument taking, fortunately for us, unfortunately for the populations, of course, and some preliminary results. We did not discuss this. I did not show this to the colleagues of the BreathIN project. They are seeing this for the first time also, okay? So I have here the daily mean values for Tomar regarding humidity and the mean daily air temperature for the month, during the September month. And you see here that those days here in Tomar were very bad regarding the relative humidity because they were below 40%. While the humidity was low, the temperatures were above 25 degrees. But these are mean daily values. And I'm going to show you the hourly values. And you are going to see that this has a huge difference for us to see a mean daily value and the hourly value. Because for the fire departments, the hourly are most relevant than the daily means. Okay? So now the particulate matter, you can see here huge peaks precisely on the 17th and on the 18th of September. You have here peaks in PM1, PM10, PM2.5, a huge peak here on the 17th. It was the orange, the big orange area that I have shown you in the image previously in the previously slide. Okay, so now hourly data. I only pinpoint several parameters. Okay, so this is the air quality index that the equipment provides. And green is good, yellow is moderated and healthy for sensitive groups, and here is hazardous. So if you can take a peek, you see that on the 14th, in some hours, we reach levels of very unhealthy already on 14th, because we also had several forest fires around in the vicinity of Tomar. Okay, so this explains the values, and of course, here you ask me, why are those values so high? Well, they are so high because some of the forest fires, the ignitions occur during the evening. So that's why I'm telling you that the human hand is behind some of those forest fires, okay? And here you can see the progression from, these are hourly data from midnight until the midnight of the other day, and a huge retention of bad and healthy air quality indexes that were maintained from also between the transition between the 17th and the 18th. Okay, so when we take a look of this, and now we gather the information related with precipitation and temperature, we see that what we would like to have in order for being able to attack a forest fire, the opposite, high percentage of relative humidity and lower temperatures. But if you see during the daily hours, that's why I told you that the hourly value, mean values are very relevant, because here on the 14th, we have temperatures above 30 degrees Celsius, and the relative humidity was very low. It was below the 30%. And this is highly dangerous to trigger. You join here winds, strong winds, and you have the triangle. For someone who wants to harm a population, to do it in perfect conditions. And here on the 17th, the same thing. You can see here the high temperatures from the midday until evening, and there is a reverse tendency between commas, between the values of humidity, the percentage, and the values of temperature. And this is explain more or less some things, but like I told you, these are only preliminary results. So let me check if I do not make a mistake in the pointer. So we have here the 14th and 18th. On the 18th here in Tomar, the situation was a little bit better regarding mean temperature, the proportion, so to speak, between the mean air temperature and relative humidity. But of course, we have also other problems. The air quality index was based upon several factors, which here are represented by three colors. The particulate matter for PM 2.5, PM 10, and PM 1. And if you see, we have on the 17th huge spikes of particulate matter PM 10, and then I will ask in a future encounter, namely Anastasia, when we are going to work with this data, trying to perceive what is behind those peaks and what can we infer from the data that we have collected precisely in this region from the monitoring equipment. So here is a huge, strong statement that we need to monitor, we need to study, and we need to talk and discuss these issues with decision makers in order for us to be able to attack the problem. So I'm proud to announce that, if you will, that our monitoring equipment is now linked to the iCare. The link is click about yes, the link is active.
Sorry.
Let's see if it works. So here you have the global network of monitoring stations from this equipment, and you can see in real time, if you please can.
I'm going to share this for presentation for people there, because the window is different. Sorry.
Okay. So if you can zoom in to Portugal, you can see a huge depression over there. Okay, so the weather is going to change here in Portugal. Yesterday it was sunny, today is not sunny anymore. And you can see here in real time several factors. And now if you please, if you can go to the other slide and click on the link that I have provided there, you can see in real time the conditions here in Tomar. My presentation is there, yes, on the other slide, please. The link is here. Those were conditions this evening, and now the real conditions are.
Just a second, because now I have to show people
Okay.
at home what they should be.
It is very good to have an assistant, a colleague and an assistant here in the room.
Yeah.
Oh Lord. So you can see that the main pollutant now is PM 2.5, and the PM2 concentration, we have a warning in Tomar, is currently 3 times over what the World Health Organization advises. So this is data that is available for you to consult in real time, and whenever you want, please feel free to go to this website. These are hourly data. Retrieve the air quality remained and the particulate matter, but go to please. The quality of the air quality here in Tomar remained not so good. We would like to be on the green because it's below 50, and we are reaching. We reach on the 27th. Between midnight and 1 p.m., we reach a peak on this window, on this display window that we can see, almost the orange color, not so good air, worsened air, okay? So this is indeed, I think, a good tool if you have diseases, chronic diseases, respiratory diseases. You can check and control. If you want to take a walk outside, please go here and see if it is good for you to do that, or if it's preferable to do it inside your house and close the windows, not ventilate in that certain day. Okay, so if you please, if you can go again to presentation, I'm going to summarize some of the preliminary conclusions that we can retrieve from here. Thank you. So next slide. Okay. Okay.
Sorry. Something happening here again.
Okay.
Oh, it's just a slide. Okay. Okay.
Okay, yeah.
It was a slide.
Yes. So I pinpoint some of keywords because this is easier. So impact, ecosystems, human health, and global climate. So these are the key points for the first note of my summary. Pollutants generated by forest fires, severe health risks, public health preparedness, and effective response systems in affected regions. We felt that in Aveiro region during September. The systems almost collapsed, okay? In certain cases, they collapsed indeed, okay? There were a huge recurrence of people to go to hospitals and the health centers and so on, that the system could not handle everyone and could not respond to everyone in proper time. So the loss of forests, urgency of global reforestation and conservation efforts. Next point, economic burden of forest fires and air pollution. From healthcare to loss of agricultural productivity, and even there were industries, schools that were closed. So all of that region was highly impacted for the forest fires. And here in Tomar, as you saw, we felt it in indoor air, in outdoor air quality also. Okay, so it is very important, and this is my highlight. Global cooperation for implementing preventive measures, promoting sustainable practices, enforcing stronger environmental protections. Also, enhancing community resilience through education, emergency preparedness, and sustainable livelihoods. These can indeed help mitigate the social impacts because those are intertwined challenges that we face, and we are going to face even further in the near future. So the reason for us to invite the municipalities around the Middle Tagus was indeed to raise a little bit more awareness, because you felt in the terrain the concerns of the citizens, and you feel their concerns, their worries, their loss of properties and so on. And from our viewpoint, the academic engagement is also highly relevant for you to be able to properly prepare us for the near future. So thank you very much. That's our preliminary results now. Thank you.
So Cristina, perhaps we can take the questions now, if you prefer, or
In the end. I do not know if Mr. Vice President wants to state something.
That was my thought, to be honest. So.
Yes.
I need to.
Yes.
I just want to say 3 words. The first one is thank you for the invitation. It's nice to be with you and learn a lot of things. The second question is give you congratulations for your work. I think you do a very, very nice work. Thank you for that. I think in the future we may talk about it because I found some ideas for my work there. Maybe we can talk about it in the future. For finish, I would like to give you. I hope you have success in your future and stay do that nice job. Thank you for everything and have a nice return for your countries. And I hope you have a lot of success. Thank you for everything.
Thank you. Okay, so our last but not least speaker, Corina Paschalidou. Corina holds a degree in physics. She has a Master of Science in Environmental Science and Engineering and a PhD in Biometeorology and Environmental Epidemiology. She has currently worked in a multi-million project about climate change risk and resilience, and in the Greek Master Project for reforestation. She is currently working in the BreathIN project, as well as in the National Group for Climate Change. We have a big project there for this purpose. And she is also working in a newly established Horizon project about climate risk ready regions. So, Corina, the floor is yours.
Hello, good morning, everyone. This presentation today is about climate change with a focus on the impact of thermal stress on public health. Okay, as we know, after the Industrial Revolution, anthropogenic activities have became the main cause driven the climate change. The main contributor is fossil fuel combustion for transportation, for energy production and industry, as well as deforestation, agricultural practices, and land use changes. It is observed that in recent decades, the rate of climate change is more intense and higher than historical records, putting an extra stress on ecosystem and often pushing them beyond their tolerance limits. We have global temperature rising. Most land areas experiencing more intense frequently and longer in duration extreme events like heat waves, extensive droughts, floods, heavy precipitation, and we understand that all these have a negative impact in almost all aspects of life. In fact, climate change is considered the most serious problem that modern societies face. Okay, here we have some data of the latest report of the IPCC. As you can see on the top right figure, we have the projections of the global temperature increase. We have for various climate scenarios. We have the most pessimistic scenarios, which project an almost linear increase in temperature till the end of the century, while on the other hand, the most optimistic project stabilization of the situation after the mid of the century. But we have to note that the optimistic scenarios require the implementation of effective and sustainable solutions immediately. So I understand that maybe it's quite difficult to achieve them. Now on the figure on the right, we see the change in annual temperature across the different regions of the world for global warming at 1.5, 2, and 4 degrees of Celsius. It's obvious that all regions have not the same response to global temperature increase. It's really interesting especially for us, the Mediterranean population, that according to the observation, Mediterranean is experiencing a pronounced decline in precipitation, along with high warming rates. In fact, the rates of warming exceeds the global average. For this region, Mediterranean is considered as a prominent climate change hotspot. Okay, considering all threats posed by rapidly changing climate and the fact that health is totally linked to well-being and quality of life, the scientific community has a growing interest about the impact of thermal stress on public health. Humans have the capability to adapt to their thermal environment through their thermoregulatory mechanisms, as well as through behavioral factors of technology, like modifying their clothes or using heating systems or air conditioning. But where thermal stress exceeds the tolerance limits of human, adverse health effects occur. These effects can range from simple symptoms like fatigue, nausea, irregular heart rate, shortness of breath, to increased morbidity and mortality from various causes, with cardiovascular respiratory being the most common. All this can affect public health and, of course, economy through healthcare expenditures, out-of-pocket costs, and, of course, productivity losses. Okay, the effects are not uniform. Among the most vulnerable groups of populations are the elderly, because of their poor ability to thermoregulate, and of course because they have already compromised health. In addition, pregnant women, as we heard yesterday, young children, population suffering from chronic diseases, and those with low socioeconomic level are also very sensitive to thermal stress. Furthermore, some studies demonstrate differences for genders. Some studies support that females are more sensitive to cold, while other studies support that men are more vulnerable to low temperatures. But in general, findings for genders differences are inconsistent. In addition, high level of air pollution can exacerbate the effects of heat. And of course, air pollution in combination with urban morphology and building materials are the cause of urban heat island. The phenomenon which describes that in city centers we have higher temperatures compared to rural areas. So people living in cities are exposed to higher heat stress. And of course, latitude and local climate is a factor affecting the exposure response relationship. Generally, we could say that people living in warm regions are more vulnerable to cold, and on the other hand, people living in cold regions are more vulnerable to heat. Okay, now I will show you some of the main findings of our study on the impact of non-optimum temperatures on mortality from cardiovascular and respiratory diseases in the Eastern Macedonian Thrace, which is our region. Okay, a few words for this region. Eastern Macedonian Thrace is located, as we can see in the map, on the
northeastern part of Greece. It has a long coastline on the south. It has mountainous areas mainly on the north side, while it has flatlands on the south and central part of the region. Of course, it has a Mediterranean climate, but this the diversity of its geomorphology contributes to have some climatic variability between the coast regions and the mainland. Interestingly, this region is a relatively poor region of Greece, and also it has a relatively high rates of AIDS population. Okay, for the purpose of the study, we collected daily data of temperature, relative humidity, and number of deaths from respiratory and cardiovascular diseases for a time period of 20 years. In order to explore the nonlinear relationship between temperature and mortality, it was followed a Poisson regression analysis for overexpressed data in combination with distributed lag nonlinear models. The lag period was extended up to 21 days in order to capture the delayed effect of cold to the mortality. The models also consider the impact of relative humidity and were adjusted for long-term trends and seasonality. All model choices and parameters were based on the Regis information criterion and of course in previous literature. All these analyses were performed for the total population and separately for subgroups, including males, females, and population age over 65 years old. Okay, to continue with some main findings. Here the plots refer to total population. And we can see a contour plot of the relationship between daily temperature and mortality. In the right, the lag response curves for exposure to extreme and moderate temperatures. Okay, if we focus on the top right figure, we can see that relative risks of mortality for exposure to extreme heat peak on the day of the exposure. This means on lag 0, and after that steeply decrease. On the other hand, the relative risks for extreme cold peaked 5 days after the exposure and then gradually decrease. This pattern was the same for the other groups of population, except for females the peaks of relative risk were 1 day after the other groups of population. Furthermore, we can see that extreme cold relative risk for exposure to extreme high temperatures falls below 1 between lag 5 and lag 10, which suggests a harvesting effect. This means that the fragile population, which would die anyway in the next period, have died because of the heat. Same patterns we observe also for moderate temperatures. Next, we can see the exposure response curve of mid-day temperature and mortality. Of course, this is a non-linear relationship as we know, and in accordance with previous literature, it depicts a U-shaped curve. The lowest extreme of the curve corresponds to the minimum mortality temperature. This is the temperature where mortality is minimized and Any deviation of these temperature signals the start of mortality. So this temperature for our region rates for 20.5 for males to 21.4 for females. If we take a closer look at extreme low temperature beyond the first percentile of the temperature distribution, we can see significant differences between two genders. The pink line is for females and the blue line is for males. So we can see that at these temperatures, females are significantly more susceptible than males. But we have to mention that this temperature rarely occur in our regions. In fact, extreme low temperatures correspond to about 1% of the total deaths understanding in this work. On the table, we can see the results from the estimations of the relative risks. It's obvious that extreme temperatures are more dangerous for population. Females are the most susceptible group of population to extreme cold conditions. On the other hand, males are more sensitive to extreme heat. And regarding the elderly, we can see that the greatest risk is posed by extreme heat. Finally, although relative risk is widely used, it is inadequate to capture the magnitude of the effect of the temperature on mortality. For this reason, we estimated the fractions of mortality attributed to moderate and extreme temperatures. As we can see, the highest rate of mortalities are caused from exposure to moderate temperatures, and in fact for exposures to moderate cold. The fraction rates from about 7.5 for males to 8.3 for the elderly. In addition, if we compare the fractions of mortality for from extreme temperatures, we can see that extreme cold has a greater impact of mortality compared to extreme heat. So to sum up, we identify the minimum mortality temperature in our region, which is around 21 degrees of Celsius. We confirm the immediate impact of high temperatures on mortality, and of course the delayed effect of low temperatures. We found that women are the most vulnerable group of population to extreme cold, and the most interesting part of our findings is that although extreme temperatures are the most dangerous, the greatest impact of mortality caused by moderate temperature, especially moderate cold. As we said, this is not a surprise and could be explained, first of all, from the fact that extreme temperatures are rarely occur. Both extreme hot and cold temperatures in our regions corresponded about 2% of the total days our understanding. In addition, maybe during the days with extreme temperature, people are more conscious and perceiving them as more dangerous. So maybe people take prevention measures. Finally, in accordance with other studies which focus on population in warm regions, we found that cold has a greater impact on mortality, which could be explained on the physical acclimatization of population to local climate, as well as by the fact that maybe people are more used to heat waves that it usually afflicts Mediterranean population and can take more easily the prevention measures, minimize the exposure and bringing order all these prevention measures. So that's the main findings that could be helpful for local authorities to build and develop strategies for prevention in our regions. Thank you very much.
Again, we have a few moments to take some questions. Questions from both Cristina and Paulina. Well, anyone here? Or home? You check. No questions?
No hands raised, I think.
Can I ask one?
Yeah, sure.
Yeah, of course.
Cristina, you had mentioned in the previous figures, the fires happened and the data was between 23rd and 30th of September.
But the main days occurred on 17th and 18th. That's why I have showed you here
So for the 17th, there was fire already.
that huge orange area that I have shown you. Yes, yes. But prior to that, around here, also spots of forest fires, but not as big and severe of those that you saw in the northern region of the country. Because then the fire spreads beyond those dates, the fire spread northwards of the country. So we had a huge impact in the quality here and in other regions. It was worse. In Aveiro, completely covered with the smoke and particles. Even I do not recall the name in English, but it like snow. It felt like snow in Aveiro. Everything covered with dust. I do not recall the name in English. I do apologize. Ashes. Yes. So it was a very severe situation.
And one for Paulina, maybe the extreme cold or the extreme heat, yeah, maybe they happen less often than the moderate ones. And
Yes.
that's one of the explanations why we would find it.
According to our data, moderate, extreme heat and cold days are about 2% of the total days, so they're rarely occur at present.
You define those percent?
Yeah,
The moderate is about the 10%.
yes, I didn't mention that it's based on literature. We define moderate heat on 19th percentile of our temperature distribution, moderate cold at 10th, and extreme sun 1st and 19th percentile. It's based on local data. Yeah.
Okay, so if I may have a comment as well. So I guess we listened to very interesting presentations.
Speak louder, please.
Yes, we have the pleasure to listen to two very interesting presentations that actually showed us
some very important impact of climate change that we are facing right now. On the one hand, we have fires, forest fires, and on the other we have public health issues. But in my opinion, both studies highlighted the importance of building preparedness, which is actually a very important step in addressing these issues. So we can be positive as long as we build this preparedness. Okay,
Of
so
course.
the measures should be taken, we should be ready.
Yes,
So,
of course, and
With a
now,
positive
of
note,
positive, yes.
we can conclude, I suppose.
Yes, we can conclude, and we are concluding. Thank you all for being present there in remotely. And today, of course, we are in few numbers here in the room. But however, I think overall we can have good results from this meeting, because this is the second meeting. We know each other better now. As a team, of course, this is highly relevant, and we know our research areas better. We can coordinate better the strategies to the other tasks that we have in hand, because the project will end only in 2026. And thank you for being here from Greece and from Cyprus, of course, for your contributions. But there is one person that I want to acknowledge the work for us in order for us to be able to be here today. It is Rosa Nico. Rosa Nico, it is not a researcher from BreathIN team, but it is a key member of BreathIN team. And I want to have an applause for Rosa. Thank you. Well deserved. So thank you all for being here, and hopefully you will go to our website. You will follow us on the YouTube channel and in social media, because we are still working on that also. And of course, we will contact you and reach you for us to give us the perception of our communications. If they indeed raise awareness, they were well conceived, they raise awareness in the academic environment, because here we have this duality. We must speak to the academics, we must speak to stakeholders, and we must speak to students. So bear in mind, I'm going to send you all a satisfaction inquiry for you to respond. Please do so. We appreciate that feedback, but bear in mind that our targets are not the academic